Hello. I will now give you an overview of the largest changes in JDK 16. This will not be a deep dive. My goal is to give you a brief summary to help you decide which features you want to learn more about. My name is Aurelio Garcia Ribeiro. I am a Senior Director of Product Management in the Java Platform Group at Oracle. I have been part of the Java team since before the release of JDK 7. Part of my job is to reach out to groups within Oracle that use Java and let them know what is coming up on future releases. We thought you would like to hear the same. JDK 16 is the first of 2 releases planned for 2021. It's the 7th release since we switched to a semi-annual release cadence, and the last release prior to the next long-term support due this September. Users of JDK 15, and for the matter 12, 13, and 14, if they haven't yet migrated, should move up to JDK 16. The next critical patch update scheduled for April will only include updates for 16, 11, 8, and for customers, 7. JDK 16 delivers 17 JEPs, which stand for JDK Enhancement Proposals, the unit of work that we use to specify the largest changes to the platform. I've grouped them into 6 categories. We have 2 changes to the Java language, 2 improvements on memory management for the Java virtual machine. There is 1 new API and 1 new tool included. JDK 16 also makes changes to prepare developers for later versions of the platform, trying to move them away from relying on JDK internal APIs and paving the way for improvements in memory management that are being developed as part of Project Valhalla. We deliver 4 features in preview or incubator to gather feedback before we add them to the platform in a more permanent way. Finally, the last 5 JEPs deliver changes that will impact OpenJDK developers and make it easier for them to contribute to move Java forward. Let's review each one of these in some detail. First, let's take a look at the language features, since these are the changes that are most likely to be visible to all developers. Changes to the language make it possible to write Java code more concisely, which makes it easier to maintain in the long run. The first change is pattern matching for instanceof. We first saw this as a preview feature in JDK 14. Not being in preview anymore means that you can use these features without any special flag, and you can now be confident that they will remain in the platform as they are in future releases. Pattern matching for instanceof allows us to express conditional extractions of components from objects in a more concise and safer manner. So let's see an example. We've all seen code like this. We have an object which could hold different types, and we want to do something if it happens to be of a particular type. In this apparently simple example, we have 3 different things going on. We have to test to see if an object is a string. If it is a string, we have to declare a new string variable. And then we have to cast the object into the new variable so we can treat it like a string. Using pattern matching, we can reduce the code into a single line that does all of those 3 things. In this example, the variable s is only created if the object is a string, and if so, it's automatically casted into the variable. If there is an else statement, the variable would not be in scope in the conditional part. Even with more advanced conditionals, the scope of the variable behaves as you would expect. For example, if I'm using AND in a conditional, since the second part of the statement is only evaluated when the first part is true, S would be in scope for the second part of the condition and in the brackets for that branch. However, if we were using OR, the second part of the expression would only be evaluated if the first part is false. If so, then the variable S would not be in scope after the OR, and try to use it in the conditional part of the brackets will give you an error. The second change to the language in JDK 16 is the addition of a record type, which was also made available as a preview first on JDK 14. Records save developers the need to write some of the boilerplate that one has to create when writing a class that simply aggregates immutable data. Take, for example, a simple class that expresses a coordinate. We only want to pass around an immutable pair of integers, x and y. But we need to get a constructor so that we can set the values. Then we want to implement equals, and of course, let's not forget about hash code. You also want to see the values if you want to use toString. And finally, we need to be able to access those values, so we need some methods to read them. Note that in this case, we don't use the traditional getX and getY, but just the name of the fields. Now, all of this code could be auto-generated by your IDE. So writing it is probably not so bad, but that doesn't help you when you try to maintain it, because you have to read it to make sure that nothing in there is anything but ceremony. Now, what if we could let Java handle this for us? Instead of saying class, we say record. When we do, the compiler can make sure that our records gets all of those required methods without having us to include them in our code. If for any reason you wanted some of those methods, for example, let's say you need a constructor that validates some of the incoming data, you just implement the constructor, and then the compiler will provide the others. That way, whatever is written is necessary, and there is no more boilerplate. Now, while changes to the language make it easier to write new code, changes to the Java virtual machine are often improvements that will benefit everybody, even people that are just grabbing code compiled in earlier versions and are just now running them as is on the future in the newer version. JDK 16 brings us two new changes to the JVM. The first one is concurrent thread stack processing. Those using the set garbage collection, which is not the default but has been available in experimental mode since JDK 11 and non-experimental since JDK 15, will see an improvement on how garbage collection is processed. With JDK 16, we moved the last important part of work that was being done in SafePoints to the concurrent phase. This removes the last roadblock for making CGC take advantage of parallel processing, and was a requirement for the CGC goal of sub-millisecond times in SafePoints. The second JVM enhancement is on the area of memory management for MetaSpace. Before this change, when the memory on MetaSpace was no longer needed, it was returned to the JVM, but the JVM in turn did not return it to the operating system promptly. With this change, the JVM now allocates memory in smaller chunks, reducing the class loader overhead and fragmentation, which makes it easier to return the unused space to the operating system. With this, the JDK will now be able to return memory more quickly, so the applications will run with a smaller total memory footprint. Now, changes to the library can either bring new functionality or make it easier to do a task when a new API is introduced. In JDK 16, we get a new API for inter-process communication and a new tool to make it easier to deliver and package Java applications. Unix domain sockets are very similar to TCP/IP sockets, but are meant to be used for inter-process communications rather than for communicating with other servers. They can be addressed by file system paths rather than Internet Protocol ports and numbers. They are more secure and efficient than using the equivalent TCP/IP loopback connections. Unix domain sockets are used by all major Unix platforms and by Windows, and this JEP will add support for the features that are common across Unix and Windows. Now, until a few years ago, the recommended way to use Java on a system was to have a single shared system-wide Java and run all Java programs on it. This was meant to save you hard drive and allow you to download Java programs by downloading only the bytecode, not a full copy of the runtime, in order to save bandwidth. Unfortunately, this means that Java applications, when they're delivered as jars, they behave differently. You first have to install a Java runtime, and then the jar, and then somehow pass the jar to the runtime. Windows users wouldn't find an entry for a Java program in the start menu if you deliver it like this. It wouldn't be listed in the add remove program list, and more importantly, it cannot be distributed using standard tools for each platform, like RPM packages and YAM repositories for Linux. Using the new packaging tool, you can wrap your application plus a runtime, and it can be either a full runtime or a smaller version if you use JLink, into something that looks like a native installer for each platform, delivering an MSI for Windows, or a DMG for macOS, or an RPM or Debian package for Linux. Now, moving a platform forward is not only about adding new features, it's also about making sure that programs behave correctly and are not doing anything that will make it harder to update future versions. One of the contracts between the maintainers of the Java platforms and developers is that there is a set of APIs that developers are welcome to use and which future versions of the JDK are likely to continue to have. In order to deliver those APIs, the maintainers of the platform use internal APIs meant to be used only within the platform and are not part of that implied contract with developers. These internal APIs are subject to change without notice, and therefore any program that relies on them might break when applying any update. Until JDK 9, these internal APIs were not documented in the list of standard APIs, but since developers have access to the source code of the JDK, they're easy to find, and once found, can be called like any other API. Now, there are warnings when compiling with those APIs, and we have warned developers in the documentation not to use them since 1996 at least. But still, many developers rely on them. Even if you yourself are not using them directly, there are many common tools and frameworks that use them for many years. So when we released JDK 9, most non-trivial applications relied on them. With JDK 9 and the introduction of Jigsaw, we gained the ability to enforce that only internal code should access those internal APIs. But if we had turned that on by default on JDK 9, that would have made it so that many libraries and frameworks would have stopped working with little notice. Instead, we chose to only add more explicit warnings on JDK 9 and said that we will wait a prudent amount of time before we start enforcing encapsulation. That was 3.5 years ago, so one could say a prudent amount of time has passed, and we're therefore now enabling strong encapsulation by default. With JDK 16, we're going from still accessible but with a warning to no longer accessible by default. And this change applies to most internal APIs, but there's a few notable exceptions. When we were looking at those internal APIs, most were being used for convenience, or there was an equivalent API that could be used instead. There are, however, a handful of internal APIs that are being used for critical functionality that is not otherwise available. For example, SandList can save. We're working on providing supported alternatives for those APIs, but until those alternatives are in place, those critical APIs, the complete list is in the JEP. It's mostly SandList and Save, Reflection, and I don't remember the other two or three. It's quite literally a handful. They will remain accessible by default and are not going to be affected by this change. Still, if you're running programs that use internal APIs, it will be possible for now on JDK 16 to relax the encapsulation of all the packages with a single command line option, pretty much reverting to the functionality as it was on JDK 15 and before. In some future version, you will have to open specific packages with an add opens for each package. Okay, so the single command line option will be removed. As part of Project Valhalla, we're working on a new type of class called primitive classes. And those classes will be used for instances that will be identity-free and capable of being inline or have a flattened representation in memory. Now, some of the classes that currently exist in Java are likely to be converted to primitive classes. Those classes are called value-based classes in the API specification. Primitive wrapper classes, such as Java Lang Integer or Java Lang Double, satisfy most of the requirements to be designated value-based, except that they continue to expose public constructors, even though they have been deprecated since JDK 9. With this JEP, we are not only deprecating them, but we're adding the tag for removal equals true, signaling that we intend to take those constructors away. You're supposed to rely instead on the factory methods for those classes. That's the example on the slide. Additionally, the JDK will now emit warnings if you try to synchronize on instances of any value-based class. You will always get runtime warnings, and additionally, when possible, you will get compile time warnings. So hopefully this will help you move away from these use cases, which work now, but won't in the future. Now, the shorter period between releases, 6 months rather than 3 to 4 years, affords us the opportunity to preview features before baking them into the standard. JDK 16 will let you try out and provide feedback on 4 such features. It's important to understand that these features are not yet ready to be considered permanent. So in order to signal that, we use preview and incubator modules. Incubator modules are used for tools and libraries, since those can be clearly constrained within the module system, and previews are used for language and VM features which cannot be contained within a module. To use preview features, developers need to pass on a flag to the compiler. And then at runtime, you need to pass a flag in the command line to enable them. The purpose of these flags is to ensure that nobody uses them unknowingly. We don't want some developer writing a library that uses preview features, compile it, and then pass it on already compiled to other developers. Have those developers build something without knowing that that library will not work as is in the next version. Now, there is no set number of times that a feature or an API has to go through either previews or incubators. Some simpler features, or features that are better understood, can be added without being any preview. Others may need 1 or 2, or even more. So far, we've only had 2 previews at most, but we do have in this release an API that has remained in Incubator for up to 3 releases. There is no hard rule. It depends on each feature and on the feedback that we receive. So with that in mind, knowing what these are for, sealed classes and interfaces restrict which other classes or interfaces may extend or implement them. In Java, a class hierarchy enables the reuse of code via inheritance. But sometimes you want to use it to model various possibilities that exist in a domain, like the kind of shapes supported by a graphic library. When the class hierarchy is used in this way, restricting the set of subclasses can streamline the modeling. What we need is a superclass to be widely accessible, but not widely extensible. So, sealed classes. In JDK 16, this feature from Project Amber comes back for a second preview. Let's look at an example. A class is sealed by applying the sealed modifier to its declaration. Then, after any extends and implements clauses, you add the permits clause. It then specifies the classes that are permitted to extend the sealed class. A sealed class imposes 3 constraints on its permitted subclasses. The sealed class and its permitted subclasses must belong to the same module. If they are declared in an unnamed module, they have to be in the same package. And every permitted subclass must directly extend the sealed class, and every permitted subclass must choose a modifier to describe how it continues the sealing. It could be final and allow no more subclassing. It could in turn be sealed, which means it will have its own set of permitted subclasses. Or it could be non-sealed. One and only one of those modifiers, final, sealed, or non-sealed, must be used by each permitted subclass. Java Lang class will get 2 new methods, so that code using reflection will be able to determine if a class or interface is sealed, and if so, get a list of the permitted subclasses. Another new API with JDK 16 is a vector API that will give developers a way of expressing computations that will reliably translate at runtime to vector hardware instructions on supported CPU architectures. Vector operations enable work to be done in a single CPU cycle so that it can lead to a significant performance gain. Now, most developers will not have to do this directly. We expect that library developers will take advantage of these APIs to optimize common libraries that most developers rely on. Once that happens, most developers will just experience those performance gains by updating to a newer version of those libraries and running on a newer JDK version. Here's a conceptual example. If the same operation can be executed on a group of values, it could be possible to load those values into vectors and execute the operations on the complete set. In this example, rather than needing 4 multiplications, 4 additions, and 4 assignments, we can get to the same result using SIMD instructions for one multiplication, one addition, and one assignment. We also get to test, courtesy of Project Panama, a couple of APIs that will make it simpler to run non-Java code, for now, specifically C libraries on x64 and ARM64 platforms. Although Java has had support for native calls using JNI since Java 1.1, this has always been hard and brittle, requiring the developer to maintain multiple artifacts, and usually requiring different tool chains because they're different in each platform. Project Panama aims at making it trivial for developers to use any native library. These two APIs provide the foundation to interact with native libraries. The Foreign Memory Access API is meant to provide a secure mechanism for accessing memory outside of the Java heap. Many programs currently accomplish this by using sun, misc, and save, which, as the name suggests, is not a safe practice. Finally, not all the work in the JDK release shows itself directly in the binaries you download. JEPs are also used to deliver improvements to the OpenJDK project. These changes are only visible to developers working on the JDK code itself. The rest of the developers and system administrators that just use the JDK to write or run Java programs will get the benefit of these changes indirectly, since they make it easier to get work done, and it's therefore the improvements in the JDK arrive faster. Now, I admit I was a bit surprised when I read the title of this JEP for the first time. This is not about letting you use C++ features in Java programs. This JEP is for developers working on Hotspot, the Java virtual machine, which is written mostly in C. So I added the brackets to clarify that this is only for the JDK source code. Now, as part of Project Scara, we migrated the source code from JDK, which used to rely on Mercurial for source control. It is now being migrated to Git, which uses significantly less metadata and has much better tooling. Then, in a separate JEP, it was discussed whether which provider should host it, whether we should self-host it or use an external provider. But the result of this was that GitHub was chosen for the code in OpenJDK. The final two JEPs are about integrating two ports, Alpine Linux and Windows on ARM, to the JDK mainline repository. Although Oracle is not yet making builds for these ports available outside of early access builds for Alpine Linux, the integration of these two ports in the mainland will make it easier for us to do so in the future. And that's it for the JEPs. Now I still have a couple of other details to cover. The list of certified configurations on JDK 16 is almost the same as the list on JDK 15. We've bumped up the minimum update of Oracle Linux and Red Hat Linux for ARM64, and we added support for Ubuntu Linux 20.10, so no surprises here. We will offer JDK 16 when it releases on March 16th under two different licenses. You can get supported JDK 16 builds under the Java IC OTA license, which allows it to be used in development, personal use, and for Oracle customers, which includes Java IC subscribers and anyone running in Oracle Cloud. Available at oracle.com/Java download. You can also get OpenJDK binaries for JDK 16 and the GPL from jdk.java.net. If you want to learn more about any of these features, I urge you to go directly to the source and visit openjdk.java.net. Each one of these JEPs has a detailed description, from which most of the text in this presentation was borrowed, but offers a lot more detail. Finally, if you want to hear more about these JEPs, including deep diving with the authors and lead developers, you should register for the upcoming developer live sessions. We will have 3 different days to accommodate different time zones. You will find me doing this same talk. Since you already saw it, you should probably hear my colleague Alina Yurenko from the GraalVM team talk about how to do fast and efficient microservices for Java, since that is the one scheduled at the same time as mine. For the rest of the day, you have to choose your own session, but don't worry, recordings will be made available for all the sessions after the last day. For more information about Java IC, visit our Java homepage, follow us on Twitter, or contact us via email. Now, I think I may have time for Yeah, a little short. Let me see. I have any pending questions? You said some critical APIs wouldn't be encapsulated by default. Are those going to remain available forever? Where is the complete list of the critical ones? Okay, the complete list is on the JEP. And no, we do not intend to keep those APIs available forever. It's only until we can find, or rather deliver, replacements to them, like we're doing with the foreign memory access API. Will the packager tool create a smaller runtime for modular applications? The packager tool allows you to, well, requires that you give it a runtime. You could choose to use the complete JDK, or as you suggest, if you're using a modular application, you can use JLink to create a smaller runtime, which will only include the components of the runtime needed by your application, since a runtime delivered with a JPackage application is not meant to be shared. So you can afford to strip out the pieces that you want to use. And this concludes our presentation, and I hope you found this useful. Thank you.